Hello, this is the next part of the Minimapper series. Last time we talked about choosing a motor driver, and we chose one, which means we're nearly ready to start schematic capture for the motor prototype board I'm building. Before I do that though, I want to talk a little bit about some KiCad setup. And this is something that I'm trying new on this project. Before now on other projects, I've just done a fairly ad hoc setup. But for the Minimapper, we're going to be making quite a lot of different boards for the project. And so I'd like to have some coherent library management and templates and things like that. So that's what I want to demonstrate today. And it's not super complicated, but we'll go through a few little things with it. So to start with, here I am in my Minimapper directory, project directory. It's a Git repository. I'm a programmer. I like to have everything in source code control, and so we'll use Git. It's useful for lots of things. The way I've organized this, I'm going to put all the prototype boards in this directory called prototypes. I've started on the motor board already, and we'll look at it in the next video. And the reason for keeping this organization is because I want to manage the libraries in a particular way. The other things in here, I've got data sheets that I've been collecting, some documents that I've made, like the motor driver comparison spreadsheet from last time, some mechanical sketches. There are some mechanical CAD models that we'll talk about in a couple of videos. But the thing that I mostly want to talk about today is this lib directory. So in here there's a symbol library, it's minimapper.lib. There's a footprint library, minimapper.pretty. There's a directory for 3D models, 3D packages, and there's a template, a KiCad project template. So the idea here is to put all of the symbols and footprints that are used for this, for the Minimapper project, for the different boards for it, in here, in these libraries, and to use only things from those libraries for making schematics and layouts. And the reason for doing that is, well, it's just a little bit more organized. It means that you can keep control of the footprints of things that you're using and so on. So anyway, let's look at the this template first. So when you make a template in KiCad, you provide a worksheet layout, and I've just taken this from a set of templates. I'll put a link in the video description that have design rules for different PCB manufacturers. I'm going to use Eisler, and this template is set up to use their 2-layer rules. So it's pretty simple. All you've got is the usual drawing layout, a little open source hardware logo. I added this. There's not much more to that. If we look at the schematic in this, you'll see that it's got a label to show that it's part of this this package of templates. That in particular, it's the one for the Eisler 2-layer service. There are global settings and preferences in here, so kind of library setup and things like that. And let me show you how some of that works. So if I look at manage symbol libraries here, and I look at the project specific libraries, there we go. It took a little while to come up for some reason. I thought I'd screwed something up. But you see there's a Minimapper symbol library here, and the path to this is relative to the KiCad project directory, and you see this is this Minimapper. In this case, it's pointing already directly at the template. We'll see how this works in a real project in a minute. But the way the path to this symbol library is specified is a path relative to the project directory, and that means that you can use the same symbol library for a bunch of different schematics, which is what we want to do here. We'll see how that works in a minute. And the same kind of thing is there for the footprint libraries. I'm sure this is now going to take ages. No, it didn't take long to show up. So it's the same kind of thing. The minimapper.pretty footprint library is made available by a relative path from the project directory. And this just allows you to use the same libraries for a bunch of different KiCad projects, which are separate boards, which are all sub-projects of this minimapper project. And a similar kind of thing is done for the 3D packages, though it requires a little bit of fiddling with the footprint files to make that work. But it's not too difficult. So let's see how this actually works in practice. I'm going to start a new project from a template, and you see there's lots of templates available in the system templates. I'm going to choose user templates, and I'm going to navigate to where this project template is. So project minimapper lib KiCad template, and I'm going to open there. And you see that there's a little icon that appears when you define one of these templates. You have to give it an icon. So we pick that one, template for minimapper subprojects using ISLO 2-layer rules. Say OK. We are going to put this in the prototypes directory, and we'll call it lib demo, because it's just a demonstration of how this library setup works. So we have the worksheet layout, we have a schematic, we have a PCB layout, and these are all taken from the template. So if we open up the schematic, you see it matches the template. If we press A to insert a symbol, and then we search for this minimapper library, you see it's immediately available in there. And I've already added a few components to it while I've been experimenting with the schematic for the motor board. So let's just pick a resistor. Let's put a resistor in here. Let's zoom in, and let's have a look at the properties. And what you see is that there's a footprint already assigned, and this footprint comes from this minimapper footprint library. And so I've been copying over things from the standard library. So if I do a software update on my machine and the standard libraries change, it won't affect the things that are in these minimapper libraries. So this is just a normal 0805. In this case, it's a hand soldering one, but I've simplified the footprint name to bring it into the minimapper library, and I'm going to use the same footprints for the same components all the time, where possible. That might change a bit for some things like bigger capacitors might need bigger footprints, and I'll have to think about that. But basically, most of the time, I'll use 805 resistors. Most of the time, I'll pick one footprint for one part and use that all the time. So this thing's got a footprint. Let's just draw a little wire around it. And then we'll do the usual dance. We'll annotate. We'll generate a netlist. And we'll take the value it says. And then we'll go to the PCB file. Here we import the netlist. Pick the netlist file. Okay, we've got one new symbol. It tells you what the footprint is. Something's stuck there. Okay, update PCB, close. And so we've got our footprint here. But the thing that I want to show you here is that this already has a 3D model assigned to it because of the way that I've set up these libraries. And so this is the idea all the way through this, to import symbols with associated footprints that have 3D packages with them, so that when you're doing schematic capture and layout, this stuff is already done. It's a little bit of work up front to make this nice, but it does mean that you're pretty much guaranteed to have a good experience when you're doing your schematic capture and your layout. So that's all I really want to say today on this. The next time we'll be starting the schematic capture on this this motor prototype board, and basically that just means laying out the motor driver chip itself and the supporting components that go with it. So there's the usual bypassing capacitor stuff, current sensing setup, and the current limitation setup that the current driver does. So I'll see you next time.